Hey there, math fans. We're just starting to talk about 3D curves in our Calculus 3 course. In here, we're going to talk about tangent lines, tangent vectors. I'm going to keep this video pretty short because I just want to show you that it is short. Ultimately, in this section, we're going to be looking at some sort of 3D curve. Look at that thing on the right. I've got some object moving around it, and we'd like to study it. Now, the hard part in 3D is that the collection of tools we want to use or whatever the questions are a little bit unclear. But we can compute the derivative and it means something. So we get this cosine of t. And the short answer is we do everything component-wise. We follow the Loveless law of the c's, which says if it starts with a c and you take the derivative, it's negative. Okay, that's really it. We can use that already to do a lot of things. The few things we're going to do is we're going to ask things like, what's the location at time 0? And that's what the original function is. And it would be 0, sine of 0 is 0, cosine of 0 is 1. But we also might want to know what is the direction at time 0. And we can plug that in. It's going to be 1, 2, 0. And I'm just plugging into these. So I always tell calculus students, in the end, you have your original function, which tells you the position. This is true even in calculus 1. And you have the derivative, which tells you the direction. Now, in calculus 1, that's slope. In this course, it's a vector. Now, that alone allows us to answer lots of questions. So let me show you those two things. So first, I'm going to show you a couple little bits here. Give me 1 second. One thing changed on me as I was setting this up. Okay, so here's the position. And we talk about the position vector as just a vector that points to that point. It's not very exciting, but the reason we write it as a vector is so that we can talk about its derivative. The derivative looks like this. Together, those give me some good information. I'm going to change the first one to blue. Okay, so there we go. Those are those two things, and we can watch them move around as we go. And actually the green vector can get longer or shorter. And I really just randomly pick some trig functions. Almost any trig functions you put in there are going to be interesting. Because it's sine and cosine, it's not going to go on forever. And so you get often these like things that double back on themselves like this. So it's not like this has a name. Maybe it does. I just randomly made one. It's very easy to make cool pictures. Okay, so let's go to time 0. Here's time 0. Time 0, the position vector is pointing right to that point. The tangent vector is pointing the direction we're going. The length of the tangent vector turns out to be the speed. So later on we'll talk about this in future sections. This we call the velocity. We say the length of it is the speed, which is the square root of 1 plus 4 plus 0. So this would be the square root of 5. And then we sometimes will make what's called a unit tangent. The unit tangent is what you get if you rescale the tangent vector, which in this case would give me 1 over the square root of 5 times 1, 2, 0. At this moment, we don't have a good reason to want to do that, but I'm going to show it to you anyways. There it is. Unit tangent is useful if you're just going to study the direction. The only other thing we really do in this section is we find the so-called tangent line, which is a nice little application of lines that we've already talked about. So if you don't remember how to find lines, I'm going to shrink this down just for a moment. Here's how that went. You wrote x equals y equals z equals. You wrote plus, 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 t, 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 and you had to have a point and a direction. If we're talking about a tangent line, then the point would be the location where you're at. So in this case, 0, 0, 1. And the direction would be the direction that you're going. In this case, 1, 2, 0. You could also use the unit tangent as the direction. That would be fine. Okay, I want to end this with the following. So that's it. That's the tangent line. We did this in class. I just wanted to give another example. Tangent line, tangent vector. This is the velocity or the direction, and the original function is the position. Okay, I'd like to finish this with encouraging you to play around with this. So what I'm going to do to end this is I'm going to cover this up. Sorry if you're still writing. And encourage you to just, because I think this could be fun for some people, to just come take, one of our things here. I'm going to show you this whole thing, cover up my face. That's for the better. And then we are going to play around with this. And I intentionally did not plan. So I'm just going to start messing around. Sometimes it's even fun to like throw in, let's say, cosine of mt, and then throw in a slider. Where did I put that m? Let's not make it m then. I think I was using something else. P, let's throw in a slider. And then you can even play around with what happens when you mess that up. That's kind of fun. Look at that curve. And then you can let it go. Wow. Quite exotic. Or you can make something more mundane. Make this t to the second. If you want to just be on the cylinder, you could make these be sine and cosine, and then play around with what the third component would be. You can make it t. You can make it t to the second. You could zoom out and see what that looks like. It's always going to be on the cylinder. You can make it more exotic. Make it cosine of mt. That's always on the cylinder. And we can analyze it and watch something go around it. So all of this we can do, this sort of analysis from just knowing that derivative component. So we're using all the calculus we already had. We're just using it in a new way. So that's sort of fun. So I encourage you to just play around with this, see what you can make happen. Let's see, let's try this. Let's do this. I have no idea what's happening. Okay, I knew that if I did a certain thing, it would give me something that's on the sphere. Look at that. Let's change. Oops, I was going to put a P here. P. Again, some of these things have names, some of them don't. But that's pretty fun. Okay, so I encourage you to play around with it a little bit and just realize that we can now find the derivative of all of those things and use it to analyze. All right, I hope that's interesting.